Well, good evening, all of you. Somebody please respond. Hello. Yeah. Write the message, something just want to write. Yeah. The voice is clear.
Yes, sir.
Right. I wish you a very happy and prosperous, blessed new year to all of you.
Thank you, sir.
Hoping
Wish
that
you the
you
same.
success in the GATE examination 2025. So let us start the new topic, calculus. Note down CALCULUS. Calculus. Let's go there. Note down the heading, calculus. CALCULUS. అదే అదొద్దమ్మా ఇదే Yes. CALCULUS. Calculus. This is actually we have two parts, ordinary and we are not concentrating on calculus for the computer science stream. So in calculus, we have different topics: limit, continuity, and differentiability. Mean value theorems, integration, and maxima and minima. These are the four important topics from which you are getting the questions. So we will finish these topics with the previous different types of models of problems given. Let us start limit, continuity, and differentiability. Please note down limit, continuity, and differentiability. Limit, continuity, and differentiability. Let you know the definition of limit. Right now, L is the limit of a function. Limit of a function f of x, at x equals to a, at x equals to a, if there exists, this is the symbol there exists, a small del greater than 0, that means positive, such that modulus of f of x minus L modulus of f of x minus L is less than epsilon. For some see here, if you want to say L is the limit of the function f of x at x equals to a, there must be there exists a del small del greater than 0 for epsilon greater than 0 be given whenever modulus of x minus a less than del. This is known as the Cauchy's definition. We don't do anything important with this definition. This definition is only for your understanding. This I want to give you one simple meaning of it. Here is a point A. There is some function f of x. So a small del means a small difference between this a minus del, and then the right side a plus del. Okay. So whenever we are approaching This is x value. When x approaches to a from left side, we are going to get a value here, and when at x equals to a, we are going to have L. When x equals to a plus n, we are going to have some value. This is f of x minus L. This is of x plus L. So modulus of minus epsilon L minus epsilon, and this is L plus epsilon. Epsilon is nothing but very small value. It depends on this is epsilon. So when you approach from left side towards this A, the function is approaching towards L. And when you approach from right side, the function is approaching towards L from the right side. Okay, this is the meaning of it. We don't do anything about this. We write it as, please note down, write it as limit x tends to a, f of x equals to L. We write it as limit x tends to a, f of x equals to L. If you are approaching from left side, that is called as left hand limit. Left, this I am writing here. Left hand limit is equal to limit x tends to a minus of x. It is calculated as limit x tends to 0 f of x means some finite value. X means some finite value. Please write. After noting this diagram in the margin, please write. Left hand limit equals to, that is, left hand limit equals to limit x tends to a minus f of x, that equals to limit x tends to 0 f of a minus h exists. Exists means some finite value. మనిషి ఉన్నాడు అంటే existed. If a man is living, we call it as exists. Okay, so exists means some finite value. And right hand limit equals to limit, if you are approaching from right side to A, limit x tends to a plus f of x. This is equals to limit x tends to 0 f of a plus h exists. If you approach from left side, that is left hand limit. If you approach from right side, that is right hand limit. When we say that L is the limit of the function at x equals to a, when x is approaching towards a, f of x approaches to L. F of x approaches to L. If left hand limit equals to L and right hand limit equals to L, if left hand limit equals to right hand limit equals to small L, then we say that L is the limit of the function. Have written. Left hand limit and right hand limit both are existed and equal to n. Then we say that L is the limit of the function. L is the limit of the function f of x at x equals to a. So now here, in order to find the limit and also define the continuity and also differentiability, we need to know this left hand limit as well as the right hand limit. Both are important. So this is the way of finding it, and this is the way of finding it. When both are equal to some value, that value will be the limit of the function at that point. Is it clear? Is it clear? Give me the message. Please send the message. Somebody please write the message. Say yes or no. No one is responding. I'm not getting the messages. Are you getting my voice?
Yes, sir.
Yeah. Is it clear?
Students, can you please
Let's
respond to this,
definition.
sir?
Yes. Is it clear?
Students, please respond, Amma.
Yes. Yes. Okay. Right. Next. Next. See. Do remember this definition. This is not required. Actually, diagrammatical representation is required. For the entire thing, in order to write the definition of continuity, in place of it, just write f of a. At a, the function value, if it is becoming as f of a, if it is becoming as f of a, L is nothing but f of a, L is nothing but f of a, then simply you can say it is continuous at the point x equals to a. F of x is continuous at the point x equals to a. No doubt. Continuity of a function continuity of a function continuity of a function continuity of a function f of x at x equals to a. Continuity of a function f of x at x equals to a. I don't want to repeat the entire definition here. The entire thing is not at all required. Just you can say one simple thing. The entire previous definition, if it is replaced by f of a, then the function is continuous at x equals to. That means you have to find the left hand limit as well as right hand limit. And both are equal to f of a. I say that it is continuous. When a function f of x is continuous at x equals to a, If left hand limit equals to right hand limit equals to right hand limit equals to f of a, both must be finite, both are equal and equal to f of a. Then you can say the function is continuous at x equals to a. It is continuous at x equals to a. Right. What about continuity? Continuity over interval. Continuity of f of x over closed interval a. I'm not removing this diagrammatical representation. Here, I'm going to say over some closed interval AB, some closed interval AB, some closed interval AB. It is A and it is B. Now the most important thing is here we are having the function f of x. Over this interval, if it is continuous, I'm taking only the points in between them. Left side to A, there is nothing. We are defining only in between them. Okay. Continuity of f of x over closed AB means left side to A, there is nothing. So in between A and B, if you won't take yes, and if you won't take B, if you won't take A and if you won't take B, but in between them, you are having infinite points. Infinite points. That means it is continuous over closed AB if first point is f of x is continuous over open interval AB. Open interval AB. Open interval means the point A and B are not taken into consideration. Only the points in between A and B were taken into consideration. How many points will you get in between A and B? You will be getting infinite points. Infinite points in between A and B. So how to verify whether it is continuous or not? Just it is a reversible process. We will identify the points in between them where the function is not defined. Where the function is not defined. For example, if the interval is -1, 1, if the function is given as f of x equals to 1 by x. Now tell me, is it continuous in between -1 and 1? That means, is it having finite value for all the points from -1 to 1, not including -1 and 1? Actually, in between them, you are having 0. At 0, 1 by 0 is not defined. If f of x is not defined at any point in between them, then it is not continuous. The simplest way of verification is verification of continuity over open interval means we just find the function values at all the points in between A and B. If there is any point at which the function is infinite, for example, for this between -1 and 1, there is a point 0, 1 by 0 is not defined infinity. So therefore it is not continuous over open interval AB. Right, this is one point. Second point is limit extends to a plus f of x equals to f of a. Because we are not considering anything left side to a. So we have considered only the values from a. So at the end, there is no left hand limit. You can approach towards a from the right side. So the limit extends to a plus f of x must be equal to f of a, and limit extends to b minus to b towards b. You can approach only from that side. There is nothing on the right side. There is nothing on the right side. This is f of x. Limit extends to b minus f of x equal to f of b. If it satisfies these two, these two, and also the above one, then you can say our function is continuous over closed interval AB. Continuous over closed interval AB. This is f of b, and this is f of a. This is only to have understanding, because this content will be given to you whether it is continuous or not for that interval, for certain interval. You can ask the verifications or you can ask the question. So if these 3 points are getting satisfied, then you can say function is continuous over closed interval AB. Is it clear? Somebody send a message. Is it clear? Yes. Now we have some four important results. And before writing that, you need to have an understanding about uniform continuity. Uniform continuity. Please write. Uniform continuity. Uniform continuity. What is uniform continuity? What is uniform continuity? So, madam, the function f of x, a function f of x is said to be uniformly continuous. Said to be uniformly continuous over a closed interval capital over a closed interval capital if there exists a small del rather than 0 such that modulus of f of x1 minus f of x2 is less than epsilon whenever modulus of x1 minus x2 less than del for some epsilon greater than 0 be given. Very simple. As I said, this is an interval. Here is a function. This is an interval I am taking 2 points x1, x2. If the difference between this x1 and x2 is very small, the difference between x1 and x2 is very small. And the function value of x1 and this is f of x2. The difference between f of x1 and f of x2. This is very small difference. Or this is the difference. When the difference between x1 and x2 is very small, the corresponding functional value is difference. This is f of x1, f of x2, and this is f of x2. The difference between them is very small. This difference is epsilon. For some epsilon greater than 0 be given small value. Small value. Whenever the difference between these points is small, corresponding functional value difference will be small. Okay, uniform continuity. We call this as uniform continuity. Right. We use this also in those results. Those results are very much useful in all the scientific aspects. Okay. So you may go to the trade market, or you may go to the hospitals, you may go to anywhere, whatever the applications of science for the mathematics required, we are going to use these things. Write down result 1. Result 1. We are going to write some important results. Please note down result 1. Result 1. If f of x is continuous over closed AB over closed AB implies f of x is uniformly continuous. Uniformly continuous over closed AB. Uniformly continuous over closed AB. But if you are having an interval closed AB, if you say that it is continuous, then definitely whenever the points difference is small, the corresponding functional values difference will be also small. F of x is continuous or closed AB means definitely if you take any two nearest points, their corresponding functional values difference also will be very small. That is uniformly continuous. Second one, if f of x is continuous or closed to AB, implies f of x is bounded over closed to AB. Bounded over closed to AB. What is the meaning of boundedness? You will be having the function value in between two finite values. In between two finite values. Boundedness means if we are inside a room, we will be bounded along x-axis and y-axis and z-axis also. So over all the three axes we are bounded. Bounded means that side and this side we are having finite structure. If the function is bounded, f of a will be finite and f of b is also finite. It will be lying in between two finite values. That is the meaning of boundedness. It will be lying in between two finite values. Okay, boundedness means if it is continuous or closely AB, then definitely the function is having finite values and its ends, left side as well as right side. Next, third point. If f of x is continuous or closely AB, f of x is continuous or closely AB. Continuous over closely AB. Then f of x times f of x times finite number of maximas and minimas. Finite number of maximas and minimas. This function which I have drawn is continuous. Okay, this is minima, this is maxima, and this is minima, and this is maxima. This is minima and this is max. You may count 1, 2, 3, 4, or 1, 2, 3, 3 maximas, and 1, 2, 3, 3 minimas. You may have finite number of maximas and finite number of minimas. Suppose if the diagram is drawn like this. You tell me now, how many maximas are there? 1, 2, 3, 4, 5, so many maximas and so many minimas. If the graph of any function, if it is continuous, if the graph of any function is like this, then there is possibility of getting discontinuity. The function may discontinuous at any time. This kind of graph you may observe in ECG or EEG, electro. What is ECG? Somebody please say what is ECG? Electrocardiograph. Your heartbeat is going to be represented as a graphical representation. If the heartbeat is like this, during that period, there is some problem. If such kind of graphical representations are more during certain period of time, then there is possibility of getting discontinuity. Okay, if it is continuous, the ECG graph must be shown like this. Okay, this is continuous graph. And the above one is above one may leads to discontinuous. If such kind of more maximas and more minimas are there, say this tells about your breathing is like maximum highs and maximum lows. It is going rapidly low. So more maximas and more minimas may leads to discontinuity. But here, if it is continuous, if a person is healthy, then definitely you may have finite number of maximas and finite number of minimas during that period of time. Then only you can say the person is healthy. If the person's electrocardiograph is like this, then there is some problem. Then doctor will ask the patient to go for some more tests, like treadmill test and 2D echo, and then after angiogram and so on. So which may tell us about the inconvenience in the blood cells. or blood vessels. Not cells, blood vessels. Is it clear? So this is having maximum number, infinite number of maximas and infinite number of. But if the graph is continuous, if the function is continuous, you will have finite number of minimums and finite number of maximums during that period of time. Okay, that is the third important point. And write down the fourth one also. Fourth one also. If f of x is continuous or close to a b. If f of x is continuous, if f of x is continuous or close to a b, and f of a comma f of b are of opposite signs. Opposite signs. Then this implies then there exists at least a value t in open AB such that this is simple such that f of t equal to 0. F of t equal to 0. F of t equals to 0. Let me draw the graph of it. Here we are having this is 0. If the graph is like this, okay, here is the point A and here is B. F of A is, as per this one, it is positive. And here F of B is negative. F of A is positive and F of B is negative. F of A, F of B both are having opposite signs. Opposite sign. Then there exists at least a point T. Here is the point T, where f of t is equal to 0. The function value on this x-axis will be equal to 0. At least there must be a point in A and B such that f of t equal to 0. This is known as intermediate value theorem. Right now, this is known as intermediate value theorem. Intermediate value theorem. Or sandwich theorem. Sandwich theorem. Sandwich theorem. Okay. Why we call it as sandwich theorem? Say one function value is positive, another function value is negative. If we are having a function such that one is positive, both are of opposite signs. Okay. There must be a point in between them, minimum one point. You may have many points. Saying that or satisfying the function value at that point must be equal to 0. Why we are saying it as sandwich? You know how to eat the sandwich. What is the procedure to eat the sandwich? Can somebody explain? I will explain. Because for you, the mic is not allowed. First procedure is open your mouth, insert the sandwich, then apply the force with your upper jaw and lower jaw. It's okay. Then, so this is positive, this is upper jaw, this is lower jaw. The force required to eat the content between them. In between the sandwich, there may be some veg or non-veg content. So while you are applying the force with both the jaws, force required to eat the content in between them is 0. Force required to eat that one is nothing but 0. Okay, that's why we call it as sandwich theorem. Normally, Europeans used to eat the sandwiches as this has been proposed by those Europeans. So we call it as sandwich theorem. As being the Indians, you may write it as samosa theorem also. Not valid. It is not agreed also. Okay. So the content or the force required to eat the content in between them is nothing but 0. That's why we call it as sandwich theorem. So these 4 important things are very much important and very much useful in practical. Okay? Is it clear now? Somebody write the message. Is it clear or not? Yes or no? No one is responding. Yes or no? Yes, write down the next definition, differentiability. Differentiability. Differentiability means you are just breaking that. If it is continuous, then only it can be differentiable. Okay. A differentiable function must be continuous, but a continuous function need not to be differentiable. So based on this, you people have got the questions many of the times in the previous GATE examinations. Right now, differentiability. Differentiability. Please write it in function f of x. Function f of x. F of x is said to be differentiable. Said to be differentiable. If limit x tends to a, f of x minus f of a by x minus a exists exists. Change in the function is function value f of x minus f of a. With respect to x minus a means we call it as the rate of change of f of x with respect to x. And the limit of rate of change of f of x with respect to x is nothing but this one. Exists means finite. It is existent means it will be a finite value. That value is denoted by f dash of a, and this is known as derivative of f of x at x equals to a. Derivative of f of x at x equals to a. Okay. So limit x tends to a, f of x minus f of a by x minus a exists. Exists means it is a finite value. Then we say that value is f dash of a, known as derivative of f of x at a. Okay, as we have got left hand, as we have got the limit, we will be having again both left hand and right hand. For single value function, f of x is a single value or single variable function. If it is a single valued or single variable function, for a single man, we will have right hand and left hand. It's in two hands. Sometimes some people may have only one hand. Some people may not have both the hands. That means left hand limit may not be existent, right hand limit may not be existent. Then it is not continuous. But for a single variable function, there will be two limits, left hand limit, right hand. Both the limits will be there. Okay, as the limit is there, that is left hand derivative equals to limit x tends to a minus f of x minus f of a by x minus a x minus a equal to limit x tends to 0 f of a minus h minus f of a by a minus h minus a, that is minus h exists. So left hand limit is going to be calculated in this manner. F of limit x tends to 0, f of a minus h minus f of a y minus h. It must be finite and equal to right hand derivative limit x tends to a plus f of x minus f of a by x minus a is equal to limit x tends to 0 f of a minus h minus f of a by a plus means a plus h, a plus h minus a, they cancel, exists. But if you want to say the function f of x is differentiable at a point A, then limit x tends to a f of x minus f of a by x minus a must be finite. You will get some value. Value is known as derivative of the function at that point. As the limit is involved, you will get left hand derivative will be calculated in this manner, and right hand derivative will be calculated in this manner. Both must be finite and both must be equal. Both must be finite and both must be equal. Then you can say that is differentiable. F of x is differentiable at the point A. Okay, so in order to verify the differentiability, definitely you people have to verify or find left hand derivative, right hand derivative, If both are finite, then only you can say that it is differentiable and equal. Both are finite and equal. Then only you can say the function is differentiable. Is it clear? Is it clear? If you say it is clear, then we will go ahead with doing the problems, previously given problems, different types of problems. We'll discuss different types of problems. Okay, just note down this, then we'll move on to the problems. Previously given problems. Write down a problem, just ask almost 3 to 4 times in the GATE examination. Three to four times in the GATE examination. Write down. The function f of x equals to the function f of x equals to mod x over first question minus 1 less than 1 x less than 1 over second question for all x belongs to real number is I'm giving you the options. Option A, continuous and differential. Continuous, CONT means continuous, DIF means differential. Not continuous, but differential. But differentiable. Please write completely. Third option, continuous, but not differentiable. Fourth option, neither continuous nor differentiable. Neither continuous nor differentiable. Can somebody guess what is the answer? You have to prove it. You need to verify it. Not only mod x, modulus of something may be given. Okay, or modulus of x cube, modulus of x square, some kind of questions also may be given. Last one. Right. First line. Various lessons. Right. Can somebody please say? Can somebody guess what is the answer? No answer. Okay, we will continue along with the procedure regarding the continuity and differential. Okay, So modulus of x means, first of all, we need to define what is mod x. Mod x. Modulus of x equals to x. For x greater than 0 is equal to 0 for x equal to 0 is equal to minus x for x less than 0. So modulus of x is having different kind of definitions or values. Whenever x is greater than 0, it is x. Whenever x is equal to 0, it is 0. Whenever x is less than 0, it is minus x. So what it says, mod x is continuous for all the values greater than 0. Mod x is continuous for all the values less than 0. Less than 0 also it is having some finite value. But during this interval and this interval are made set of real numbers. In this interval you are having 0. In this real number, set of real numbers also you are having 0. So we have to verify continuity and differentiability at the point 0. Because for all the points greater than 0, it is continuous. For all the values less than 0, it is continuous. So we have to verify the continuity at x equals to 0. Please note down. We have to, for the given two problems, we have to verify the continuity at x equals to 0. At x equals to 0. Okay. So at x equals to 0, we have to verify. Left hand limit is equal to limit x tends to 0 minus of x. Limit x tends to 0 f of 0 minus h is equal to limit h tends to 0 modulus of 0 minus h. Modulus of 0 minus h. If you put h equals to 0, this will be 0. Say any doubt? Any doubts, sir? Please respond with the message. So in the same manner, find right hand limit. Right hand limit equals to limit x tends to 0 plus f of x. This is equals to limit h tends to 0 f of 0 plus h. Limit h tends to 0 modulus of 0 plus h is equal to 0. Both left hand limit existed, right hand limit existed, and both are equal to the function value. What is function value? F of 0. So here left hand limit equals to right hand limit equals to function value at 0. Function value at 0. F of 0. This is f of x. F of x equals to mod x equals to this one. All these you are having here. So tell me, is it continuous or not continuous? Tell me, is it continuous or not continuous? Please speak out. Or you send the message. Continuous or not? Left hand limit equals to right hand limit equals to function value at 0. Therefore, it is continuous. Continuous. So option A or option C are correct. Option B and option D are out. Now we need to verify the differentiability. Same at the point x equals to 0. You know the differentiation. The derivative of x is 1. For all the points greater than 0, it is differentiable. Derivative of minus x is minus 1. For all the points less than 0 also, it is differentiable. But what is happening at x equals to 0? That you have to verify using this definition. Okay. Now, verifying the differentiability. Verifying the differentiability at x equals to 0. At x equals to 0. At x equals to 0. Left hand derivative. Limit x tends to 0 minus f of x minus f of 0 by x minus 0. This is equal to limit h tends to 0 f of 0 minus h minus f of 0 by minus h. Minus h. This is equal to limit h tends to 0. F of 0 minus h is 0 minus means this one. Minus of, you need to write the modulus. If you want, you can write modulus 0 minus h. F of 0 is 0. Fine. Minus h. So 0 minus h, modulus of 0 minus h is limit h tends to 0, modulus of anything will be always positive. H by minus h. So the value is minus 1. Exists. Value is minus 1 exists. Next. Right hand derivative is limit x tends to 0 plus f of x minus f of 0 by x minus 0. It is nothing but limit x tends to 0 f of 0 plus h minus f of 0 by h. So this is equal to limit h tends to 0. F of 0 plus h is modulus of 0 plus h. F of 0 is 0 by h. Modulus of h is always positive h. So limit h tends to 0, h by h. Positive value by positive value. It is nothing but 1 exists. Tell me your conclusion. It is differentiable or not? Both are equal, huh? It is minus 1 and it is plus 1. Huh? Differentiable. Right. It is minus 1 and it is plus 1. Left hand derivative and right hand derivative both are existed but not equal. They are equal, then it is differentiable. If they are not equal, it is not differentiable. Please write. Here, left hand derivative here, left hand derivative and right hand derivative are not equal. Therefore, the function is not differentiable at 0. Not differentiable. Yes, not differentiable at 0. Not differentiable at 0 means 0 is included in this interval. 0 is also included in this interval. If it is not differentiable even at one point, it is not differentiable over the entire interval. So the answer is it is continuous but not differentiable. It is continuous but not differentiable. Once it was asked for this interval, another time it was asked for this interval. And once it was asked for mod x whole cube, the same answer. Mod x whole cube, same answer. Okay. So this is very, very important, and this is the question regarding the continuity as well as differentiability. First, you need to know this nature of the modulus. Okay. So if everyone have written, I'm arising. Now, if the question is asked like this, what you will do? If the question is asked for f of x equals to modulus of x plus b, what you will write? F of x equals to modulus of x plus b means x plus b for x plus b greater than 0. That means x greater than minus b by a. For x greater than minus b by a. And it is 0 for x equals to minus b by a. And it is minus of x plus b for x less than minus b by a. If this kind of function is asked or given, then you have to split that function into this station. You need to define the modulus like this, and you have to verify the continuity as well as differentiability at x equals to minus b by e, not 0. Previously only mod x. A is 1, B is 0. So then we have written like this. Now if it is modulus of x plus b, you have to write the definition and you need to verify continuity and differentiability at minus b by a. You may write it as a note. Write it as a note. If the problem of verification of continuity and differentiability, continuity and differentiability, continuity and differentiability. Ask for f of x equals to modulus of x plus b. Ask for f of x equals to modulus of x plus b. Then we need to write that as given and have to verify continuity and differentiability at x equals to minus continuity and differentiability at x equals to minus p by a. So almost we have covered very important method. Okay. So based on it, you may expect. And another type of problem is found down. Which was also asked in the previous state examination. Right now. A function f of x a function f of x is defined as f of x equals to x power b into sine of 1 by x. X power b into sine of 1 by x for x not equal to 0 and 0 for x equals to 0. Zero for x equals to 0. And it is differentiated. It is differentiated at origin or differentiable at origin. Differentiable at the origin. Provided 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 small p being provided small p being. That means we need to say about the value of p. Giving you the options. Yes. Is any is equal to is any number x p is anything z rather than 1 rather than 1. Note down these options. P is z rather than 1. Okay. We have given that it is differentiable at origin. Differentiable at origin means it is obviously continuous. As I said, you may take it as a note also. I'll explain. You can take it note afterwards. It is already continuous origin, and it is already differentiable. That means left hand derivative exists, right hand derivative also exists. Right now, given that it is differentiable at origin, then that it is differentiable at origin. Therefore, right hand derivative is equal to limit x tends to 0 f of 0 plus h minus f of 0 by h Exists. Exists means finite. Finite. That equals to limit h tends to 0. What is f of 0 plus h? 0 plus means first part you have right. 0 plus h whole power p into sine of 1 by 0 plus h minus f of 0 is 0 by h. Must be existed. Must be existed. That equals to limit h tends to 0. H power p by h. H power p minus 1 sine of 1 by h must be finite. Okay. Now for what value of p will be finite? That you have to verify as per the options. Now the most important thing that you need to observe here is, come on, as h tends to 0, 1 by h tends to infinity. Now sine of 1 by h. Tell me what it is. Is it 0 or infinity? Or it lies in between 0 and minus 1 and 1? Normally, you people may say that sine theta is always lying in between minus 1 and 1. Sine theta lies in between minus 1 and 1. Provided theta is finite. But here, the angle 1 by h is not finite. So sine of 1 by h will be infinity. Okay, since it is infinity, since sine theta lies in between minus 1 and 1, and theta is finite. Provided theta is finite. But here the theta is not finite. Therefore, sine of 1 by h will be infinity. You have to remember this. It's very, very important. So this is infinity. Now I am verifying the options one by one. For option A, if p equal to 0 implies right hand derivative limit h tends to 0 h power p minus 1, that is 1 by h into sine 1 by h. This is equal to, as h tends to 0, 1 by h will be infinity. So you have to write in tends to infinity. Sine of 1 by h is also infinity. Tends to infinity. Defined or not defined? Defined or not defined? Not defined. But it must be finite. So not finite. So p equal to 0 is not correct. P equal to 0, this right hand derivative is not finite. But as per the statement given in the problem itself, it is differentiable. Differentiable means right hand derivative must be finite. Second verification, if p equal to 1, if p equal to 1, what is that right hand derivative? Limit h tends to 0, h power 0 is 1, sine of 1 by h. So what is it? It tends to 1 into infinity again tends to infinity, again not finite. So this is also not correct. This is also not correct. Next. But it is given as differentiable means it must be finite. I am verifying for option C. Any real number. Let us take p equal to -1. This implies right hand derivative. Limit extends to 0. -1 means 1 by h square sine of 1 by h. So it is totally so infinity into infinity, infinity, not finite. So C is also not correct. C is also not correct. Now, obviously, he will be the answer. If you want, you can verify with an integer greater than 1. Greater than 1 means obviously it is positive. Let us consider p equal to 2. An integer greater than 1. Limit h tends to 0. It is greater than 1. This 2 means 2 minus 1. H power 1 into sine of 1 by h. It is equal to or tends to h is 0. 0 into infinity. 0 into infinity is always equals to 0. Finite. Finite. So this is correct. We have given that it is differentiable at origin. Differentiable at origin means it must be finite. So that is satisfied only when p is an integer greater than 1. Not for any real number. Any real number means it also must satisfy one negative real numbers, negative value. P equal to 1 phase, equal to 0 phase. We have verified. Any real numbers we have verified for negative integer. So it is right. So option D is correct. This was also asked in the previous GATE examination. So if it is given the statement that it is differentiable, so by using the definition, verify the options. You will get the answer. So simply verifying options. Is it clear? Say yes or no, clear or not? Yes? No response. Or if you have any doubt, you may ask. Okay, right. Right, next another question. This also depends on the verification based on the definition. Just only to verify the continuity. So let us do it quick, make it fast. Which one of the functions is continuous? Which one of the functions Which one of the functions Which one of the functions yes, x equals to 3. Option A. F of x equals to visible? Yes. 2 if x equals to 3. X minus 1 if x greater than 3. X plus 3 by 3. If x less than 3. Option B. F of x equals to 4 if x equals to 3. 8 minus x if x is not equal to 3. Of x equals to x plus 3. If x less than or equal to 3. X minus 4 if x greater than 3. Option B. F of x equals to 1 by x cube minus 57. If x is not equal to 3. Just verify all these four. Make it click fast. Just you have to verify all these options. Which of the following functions is continuous at x equals to 3? You know what is left hand limit? What is right hand limit? And just find both are existent and both are equal. Then you can say the function is continuous at x equals to 3. Keep on starting with option A. Just now, right now. Right now. So are you doing now? So okay. Let us start with option A. What is left hand limit? Limit x tends to 0. F of 3 minus 8. We are verifying the continuity at x equals to 3. So this is equals to limit x tends to 0. 3 minus means this one. In place of x, write 3 minus which? plus 3 by 2. So as x tends to 0, it is this 6 by 3. Nothing but 2. When x equals to 3 is 2. So f of 3 is 2. Function value at 3 is equal to left hand limit. And find right hand limits. Limit x tends to 0. At 3 we are finding 3 plus h. Limit h tends to 0. So what you can do? 3 plus means this one. 3 plus h minus 1. 3 minus 1, it is 0, it is 2 again. It is also equal to f of 3. So left hand limit equals to right hand limit equals to f of 3. Function value at 3. So the function is continuous. So the function is continuous at x equals to 3. So actually among those 4 options, only one will be correct. But fortunately, by verifying the first option, we have got the answer. If you want to go for the next, the last one, this definition is not clear. Function value at 3 is not defined. That's why it is not continuous. At x equals to 3, what is this? It is not defined. So option D is not continuous. Okay, that's this one also. Here what you can say, f of 3 will be 3 plus 3, 6. Now again, if it is greater than 3, right hand limit, 3 plus h minus 4. So this is minus 1, that is 6. Right hand limit is not equal to this value. It is also not continuous. And for this, you may find the left hand limit 8 minus 3 minus h. So 8 minus 3 is 5. But x equals to 3, it is 4. So left hand limit is not equal to the function value. So therefore it is not continuous. Very easily you can verify it. If you verify for these 3 also, you may clearly get the function is not continuous at x equals to 3. Is it clear? Somebody say it is clear or not? Say yes or no. You want me to explain this again? Yes, please. Please respond. Yes, please. Respond. Yes. Next. Write another different type of problems. That is indefinite limits or indeterminate limits. Indeterminate limits. Indeterminate. Write down. Indeterminate limits. Indeterminate limits. Indeterminate limits. A limit extends to a f of x by g of x. If limit extends to a f of x by g of x. F of x by g of x is of the form is of the form 0 by 0 or infinity by infinity or infinity power infinity and so on. Zero by zero or infinity by infinity or infinity power infinity and so on. By substituting x equals to a in both numerator and denominator. X equals to a both numerator and denominator. Then such limits are known as indeterminate limits. Such limits are known as indeterminate limits. Indeterminate limits. So to evaluate this, limit extends to a of x by of x equal to f dash of a by g dash of a, provided if it is finite. It is finite. And g dash of a not equal to g dash of a not equal. Uh, 15 minutes wait. G dash of a not equal to 0. If here, if the numerator is finite, it may be 0 or any value, but denominator must be not equal to 0. If denominator is 0, then what we can say? It will be infinite. It is not defined. And this will be equal to f double dash of a by g double dash of. When g dash of a equal to 0 and g double dash of a not equal to 0. And this is equal to f triple dash of a by g triple dash of a. G triple dash means differentiate the function 3 times and then put x equals to a. And here also differentiate the function 3 times and then put x equals to a. If when g dash of a equal to 0 and the first derivative value at a is 0 and g double dash of a also 0 and g triple dash of a not equal to 0 and so on. And so on. This is known as L'Hospital's rule. This is known as L'Hospital's rule. This is known as L'Hospital's rule. L'Hospital's rule. So for this indeterminate limits means they must be on the form, in the form 0 by 0 or infinity by infinity or infinity for infinity. All these are known as indeterminate forms. While substituting x equals to a in both numerator and denominator, we call them as indeterminate form. So for such kind of limits, we have to use this. This is known as L'Hospital's rule. No. Did you finish? Did you finish? Say yes or no. Quickly we do the problems given in the previous examinations related to this. Very simple questions were asked. Very simple questions. Okay. Yes. Let me write limit theta tends to 0 sine theta by theta. Can somebody say the value? This is also asked in the GATE examination. Can somebody say the value? Quick, fast. If you put theta equals to 0, sine 0 will be 0 and denominator is also 0. It is in indeterminate form. So use L'Hospital's rule. This is equals to limit theta tends to 0. Derivative of sine theta is cos theta. Derivative of theta is 1. D by dt of sine theta. Differentiation. You pick just everybody. Please go through the previous differentiation formulas. Okay. So then you will be recollecting them and you can do better. Without that, it is not possible. You cannot do the calculations. Calculus means doing calculations based on the differentiation and integration and also the applications of the differentiation. That's enough. And both of these two, you must be aware of this. Otherwise, you will not get the marks in ordinary calculus. Ordinary calculus also, you may expect 2 to 3 marks. Sometimes 2 questions or sometimes 1 question. Okay. So, derivative of sine theta is cos theta. And d by dt of theta is 1. Or theta for n. We write it as n into theta power x. Okay. So we have got this. And what is the value of it? If you put theta equals to 0, cos 0 is 1. The rest of the matter, they got 1 mark or 2 marks. Differentiate both numerator and denominator separately. So substitute, then you are getting the answer as 1. Next question. Next question. Limit x tends to 0. 1 minus cos x by x square. Do it quick. If you put x equals to 0, 1 minus cos 0. 1 minus 1 by 0. Again, it is on the form 0 by 0. So it is an indeterminate limit. So apply L'Hospital's rule. Do it quick, make it fast. Yes, please, what is the answer? Can somebody say what is the answer for this? This was also asked in the GATE examination. Doing the differentiation once. Limit x tends to 0. What is derivative of 1? Derivative of 1 is 0. Derivative of cos x is minus sin x. d by dx of cos x is d by dx of cos x is minus sin x. And derivative of x square is 2x. Again, if you substitute x equals to 0, sin 0 will be 0. And again, it is in the form of 2 into 0, 0 by 0. Again, it is in the form of 0 by 0. Ask him to come by 7 o'clock. 45 or 7. Leave it. Also leave it. Again, it is in the form of 0 by 0. So, what you will get now? Do the L'Hospital's rule one more time. With x tends to 0, derivative of sin x is cos x. Derivative of 2x is 2. Okay. So cos 0, x equals 0. Cos 0 is 1 by 2. This is cos 0. Cos 0 is nothing but 1. 1 by 2. Answer is 1 by 2. Finished. Say yes or no. No response. No response. Quickly, I'll give you the values for cos, sin, for sin. 0, 5 by 6 is 30, 5 by 4 is 45, 5 by 3 is 60, and 5 by 2. For sine it is 0, 1 by 2, 1 by root 2, it is root 3 by 2, it is 1. For cos, simply you have to reverse it. 1, root 3 by 2, 1 by root 2, 1 by 2, 0. For tan is nothing but sin by cos, 0 by 1. This by this, by root 3. This by this, 1. This by this, 3. 1 by 0, infinity, not defined. For cot, reverse this. Infinity, root 3, 1, 1 by root 3, and 0. For secant x is nothing but 1 by cos. 1 by cos. What is 1 by cos? 1 by 1, 1. By this, 2 by root 3. And secant, this is root 2. 1 by cos. Secant is 1 by cos x. Okay, tan is sin x by cos x. Cot is 1 by tan x. So this is root 2, 2, and 1 by 0 infinity. Okay. And again, cosecant x. 1 by sin x. Reverse this otherwise. 1 by sin is 1 by 0 infinity. This is 2. This is again root 2. This is 2 by root 3. And cosecant 1 by 1, 1. Okay. Note this one. This is useful when doing this kind of values. In order to find these values, we need it. But today, we'll discuss one more problem, and tomorrow we'll discuss some more, a few of the important problems which we can expect are important previous year examinations. And afterwards, we will continue mean value tables, the next important one in this calculus. Have you noted this? Say yes or no. Have you noted? Yes. Now write down next question, which is also given in the case. I'm giving you different kind of problems. If it takes time to apply this L'Hospital's rule, limit x tends to 0, e power x minus 1 minus x by x cubed. Do it quick. Do it quick. But if you substitute x tends to 0, e power 0 will be 1. So this is 1 minus 1. This will be 0 and 0 by 0. Again, it is in the form of 0 by 0. So it is an indeterminate limit. If you keep on doing differentiation, derivative of e power x will be e power x. So you will be doing the differentiation for this, for x cubed. First derivative is 3x squared Again, substituting x equals to 0, denominator will be 0. Next derivative is, second derivative is 3 into 2x, 6x. By substituting x equals 0, again that will be 0. So L'Hospital's rule, by applying up to 2 times, you are getting 0 by 0. Again, third time, you will be getting some value. Instead of doing this repetition of differentiation for more than 2 times, we can write one more thing, that is the expansion of e power x. Expansion of exponential or trigonometric or hyperbolic functions. So e power x expansion is 1 plus x by 1 factorial, x square by 2 factorial, x cube by 3 factorial, x power 4 by 4 factorial, plus so on. Do write this one. This is the expansion of e power x. Okay. How you are getting these expansions, we will be discussing in the next class. That is in mean value theorems. Mean value theorems, you can easily observe how you are getting these expansions. Just simply an application of Taylor series or Maclaurin series. But for the sake of this problem and some more, just do remember this. Now, I don't know, this is in the form of 0 by 0. I'm just writing the expansion. X tends to 0. E power x is 1 plus x plus x square by 2 factorial, x cube by 3 factorial, x power 4 by 2 factorial, plus 1, minus 1, minus x square by 2. All divided by x2. All divided by x2. So what we are getting? 1 minus 1. X minus 1. X square by 2, x square by 2. This gets cancelled. The remaining are these only. So among all the numerator terms, limit x tends to 0. Among all the numerator terms, x cube can be taken common. 1 by 3 factorial plus x by 4 factorial plus 1. All divided by x cube. So x cube gets cancelled. Now simply applying or substitute x equals to 0. So this is 1 by 3 factorial. Hereafter, x by 4 factorial, x square by 5 factorial, all these will become 0 plus 0. 1 by 3 factorial is 1 by 6. That's enough. Again. Is it clear? Come early. Earlier, early. Is it clear? Say yes or no. Right. Right. So now I'm going to give you one more problem. So you just try to do it by tomorrow. Otherwise, I'll explain tomorrow evening. Limit x tends to 0, e power x minus x square by minus x square by x square plus x into log of 1 minus x to bc. X into log of 1 minus x to the base e. Just you have written the expansion of e power x. I'll give you the expansion of sin x and log 1 minus x. Try to substitute and simplify it. Actually, it is also an indeterminate limit. If you put x equals to 0, e for 0 is 1. Sin 0 is 0. 0, 0 is 0. 0 plus 0 into anything is 0. So 0 by 0. It is in the form of 0 by 0. But if you keep on doing the differentiation, e power x sin x, product formula of differentiation, repeatedly we get the terms in the numerator and denominator. Log of 1 minus x derivative is 1 by 1 minus x. Another derivative is minus 1 by 1 minus of 1 minus x whole square. So keep on getting the derivatives numerator as well as denominator. In such case, you have to use these expansions. I have given you e power x. So let me write sin x expansion. X plus x cubed by 3 factorial. Sorry, minus plus x power 5 by 5 factorial minus x power 7 by 7 factorial plus 1. This is sin x. And log 1 minus x expansion. Minus x squared by 2 minus x cubed by 3 minus x power 4 by 4 and so on. Use these expansions, simplify, then substitute. We'll get the answer. These are also indeterminate limits. They're all indeterminate limits, but those whose derivatives are recurringly occurring. Recurringly occurring means the derivatives are never ending. They're continuously occurring. For such kind of things, you have to use these expansions. By using these expansions, try to get this value out. And I'll explain the answer better. Any doubt? If you have the doubt, you can ask me now. Any doubt? Please respond. Any doubt? Yes, yes. Any doubt? Respond, please. Quick. Okay. So you just try to do this one. And tomorrow we are having 2 more simple models. After discussing them, we'll discuss mean value theorems. So based on mean value theorems, actually we can write these kind of expansions, and these are also very useful in order to do the problems in calculus. Okay. So in artificial intelligence, all these are very much required. That is in the future. Okay. So those we will discuss tomorrow. Okay, then we may continue tomorrow. Good night. You can take leave.